18 electron rule. The formula of this 18 electron rule is, in the complex, the sum of the valence electrons of central metal atom or ion and the electrons donated by the ligands should be equal to 18. Any complex which satisfy the 18 electron rule are stable because these 18 electrons in the complex which closely resemble the ns2 n-1 d10 np6 d orbital configuration. This configuration is stable because in these orbitals all are filled with electrons. If we count these electrons, these are 2 plus 10 plus 6, total 18 electrons, completely filled orbitals. Therefore, if any complex which satisfy the 18 electron rule, that complex is stable. For calculation of 18 electrons in a complex, we should remember the valence electronic configuration of central metal in the given complex. We should also know how to calculate oxidation state of central metal in a complex. Let's take one example, FeCN taken 6 3-. In this complex, the central atom is iron. The valence electronic configuration of Fe is 3d6 4s2. Now we will calculate the oxidation state of this iron in this complex. Let's take iron as X and place here 6 ligands, 6 cyanide ligands, 6 into each ligand have -1 charge. -1 is equal to overall charge on the complex is -3. So if we calculate X is equal to -3, 6 into -1 -6. If we take this -6 to right side, it will become +6. Therefore, X is equal to +3. Here the charge of the Fe in this complex is +3. Plus charge representing the loss of electrons. That means in this complex iron lose 3 electrons. So if we write Fe3 plus configuration, it is 3d5 4s0. That means 2 electrons lose from s orbital and 1 electron lose from d orbital. So this is the electronic configuration, valence electronic configuration of Fe3 plus. In this complex, cyanide ion donate 2 electrons to the iron, means 6 CN ligands donate 6 pair of electrons to iron. So from 18 electron rule, sum of the valence electrons of central metal atom or ion and electrons donated by ligands. That means if we have valence electrons 5 plus 6 cyanide ligands into each one donated 2 electrons, which is equal to 6 into 2, 12 plus 5, which is equal to 17 electrons. That means it is not satisfying the 18 electron rule. Therefore, the complex is unstable. Take one more example, CONH3 taken 6 3-. In this complex, the central atom is cobalt. Cobalt valence electronic configuration is 3d7 4s2. So now we will calculate oxidation state of cobalt. In this complex, ammonia is a neutral molecule, so it doesn't contribute any charge to cobalt. Therefore, the overall charge on the complex will be the oxidation number of cobalt, that is cobalt 3+. Now remove 3 electrons from this configuration, we will get 3d6 4s0. Now in the valence shell it have 6 electrons and each ammonia donate 2 electrons. Total 6 NH3 molecules. 6 into 2 12. Now the 18 electron from this complex is 6 from this valency plus 6 ligands. Each ligand donate 2 electrons, which is equal to 6 plus 6 into 2 is equal to 12. Total 6 plus 12 is equal to 18 electron. Therefore, this complex satisfying 18 electron rule and this is a stable complex. Third example, CrCO6. Chromium have valence electronic configuration 3d4 4s2. So, in this complex, CO is a neutral molecule. It doesn't contribute any charge to chromium. So, its charge is oxidation number is 0. Therefore, the total electrons present in the Chromium is 4 plus 2 is equal to 6. Now calculate 18 electron for this 6 place. Each ligand, 6 CO ligands, donate 2 electrons, 6 into 2. So which is equal to 6 plus 12 is equal to 18. This chromium CO6 also satisfying 18 electron rule. This is a stable complex. Example, nickel chloride complex. In this, nickel is a central atom. Its valence electronic configuration is 3d8 4s2. Now calculate the oxidation state of nickel. Let's take nickel as a X place. Here 4 chlorines. So each chlorine it has charge -1, which is equal to overall charge on the complex is -2. So X is equal to -2. 4 into -1 -4. If we take -4 to right side, it will become +4. Therefore X is equal to +2. The charge on the oxidation state of this nickel is +2. That means it loses 2 electrons. The valence electronic configuration of nickel 2 plus is equal to 3d8 4s0. 2 electrons lose from s orbital. Now calculate 18 electrons in this complex. Here it have 8 valence electrons from the metal ion plus 4 chloride ions. 4 into each chlorine donate 2 electrons, which is equal to 8 plus 16 electrons. It is not satisfying the 18 electron rule. In this way we can calculate the 18 electrons in a complex. This is about 18 electron rule.